Are you struggling with a student's neatness or lack thereof in their math equations? Did what we try work with our students? Stay tuned until the end to find out. It's a beautiful day. My name is CJ and welcome to Discussion Dive. Let's talk about neatness in math. Do you have a student whose lack of neatness is actually contributing to their errors, and no matter how much you remind them to be neat, or no matter what you do to assist, nothing changes? You are not alone. As you can see from these examples, this student was really struggling when writing out their equations. Now, part of the problem, if we want to use that word, is admittedly the worksheets themselves. These worksheets do not provide a lot of room, and being blank, do not provide a visual reference for the student when writing out their equation. Quick side note, I am not actually going to get into a review about this particular math curriculum in this video. But we do absolutely love this math curriculum. We have used it for many years and we plan to keep on using it because it does work so well for our students. So be sure to keep an eye out for a future follow-up video reviewing our favorite math curriculum. Now, striving for neatness in math is not meant to be a punishment or to be nitpicky in exercise. Neatness in math helps to teach logical steps as well as the ability to troubleshoot and find errors. Teaching and insisting on neatness in math is teaching a skill set. Whether or not your student is planning on pursuing higher math in college or university, developing neatness now will stick with them, and it assists in establishing a new pattern for many different skills, from construction to budgets to various life projects. So what did we do to help teach our students a new pattern? We did two things. We modeled our expectations in a larger than life format before providing them a matching support for the students to use on their own. In order for us to model the expectations we had, we created a larger than life grid where we could write down the equations on the board to demonstrate how each equation should look. To create this board, I researched a variety of different options, tips and tricks, and I experimented with different possibilities before finally finding one that works. First, I attempted to create a grid with an item called whiteboard tape. This tape comes in many different styles and colors, and the plan was to use this tape on our existing large magnetic whiteboard. I tried both a paper tape as well as a vinyl tape. However, I encountered two problems with these. The first problem was when I erased the equations. The dry erase markers being erased would smear into the tape and cause residue that would smudge all over the grid, creating a huge mess after only one or two uses. Secondly, I needed the grid to be temporary if I was going to use it on my large whiteboard. When I tried to remove the tape from the test board, it left residue and chunks behind and would have destroyed my large board. So I am so thankful that I did not go full on with this method right from the start. And the other method I tried was a permanent marker grid. During my initial research, some sites and posts had suggested that permanent marker would be a great method. However, I must admit I had my doubts from the very start. Because if you have accidental permanent markings on a whiteboard, a great way to get rid of them is to cover them in dry erase marker and then erase. So how could permanent marker then work for a permanent grid if dry erase marker removes permanent marker? I was slightly confused. Nevertheless, you never know until you try. And of course, as Miss Frizzle says on the Magic School Bus TV show, take chances, make mistakes, and get messy. So what else could I do but give it a try? And no, it did not work. The permanent marker wiped off right away when I wiped off the dry erase marker. But why does this happen? Well, the permanent marker is removed because of the solvent that is contained in the dry erase markers that makes your dry erase markers dry erase. Don't take it for granted though that you will always be able to remove permanent marker using dry erase. However, it is a great trick to try just in case that happens. Tell me in the comments below, do you have a whiteboard that you use for your students? If so, what do you love to use it for? And if you don't have one, what is a tool that you use instead that works great for you and your students? And don't forget to hit that subscribe button and give a thumbs up as well. So the tape didn't work, the permanent marker didn't work, and I really wanted to make use of this grid idea. So now what? Well, after mulling it over for quite a while and doing some additional research, I decided to pick up a sheet of acrylic from our local hardware store and draw a grid of 1-inch squares using permanent marker on the back of the sheet. This way I could write on the opposite side and not worry about racing the grid itself. How did I make it? First, it was necessary for me to decide what size of board I actually required. I selected several different sample equations from our current workbooks and counted how many numbers and operations were present in a single line of that equation. I then added a few extra spaces for equation future-proofing to accommodate longer, more complex equations, and I counted how many lines these equations required to complete the process of the equation, and then allotted a 1-inch square to each of these. This gave me the total minimum size of grid that would be required, which was approximately 30 inches by 20 inches. Now, based on my local prices and what was available to me at our local hardware store, I did upsize the board and I ended up selecting a 45-inch by 32-inch board, as I thought there would be value in going with a larger option. There are a number of different brands, types, and styles of acrylic sheets available depending on where you live. So head on down to your local hardware store to see what options are available to you in your local area and what your local prices are like. What did I learn from this upsize? Go for it, absolutely 100%. Do not go smaller, go bigger. Having the extra room has been essential for additional equations, showing alternatives, explaining concepts. I am so thankful that we went larger. I actually think I would have been really disappointed and frustrated in the long run if we had gone with the size that I was initially looking for. Once we had our piece of acrylic, it was time to draw the grid itself. In order to draw the grid, I used a large tool called a carpenter's square to mark out the 1-inch segments all around the outside edges. And then I connected the dots with straight lines. Any long ruler or straight edge will work for this. Do try to use a straight edge that is as long as or longer than the lines that you are drawing so that you can ensure an clean, even line start to finish. I drew the grid lines using ultra-fine black permanent markers. I ended up using 3 pens in total for the entire project. It is not that the initial pens ran out of ink per se, but they stopped being happy, as I like to say. What I mean by this is that the lines were no longer applying evenly on the acrylic surface. So I would set that pen aside, grab a new one, and I went through 3 of these. After all this work, how do I feel about the end result? I love our larger-than-life dry erase grid. I set it up on the ledge of the large whiteboard when I need it, and then lower it down to the floor out of the way when it is not in use. My large whiteboard is also magnetic, and I do use a small magnetic clip to secure the acrylic grid in place when it rests on the ledge to ensure it doesn't fall off. I do think I'm being overcautious. I'm not sure that the extra clip is actually totally warranted, but tell you what, it gives me peace of mind, so I'm going to keep on using it. If you don't have a ledge like this to use, try a table, an art easel, the top of a short bookcase, a window ledge, or even just sit on the floor. Make use of whatever you have available to you. And how did we actually incorporate this grid into class? Well, we initially took a break from learning any new math concepts and spent a few days introducing existing concepts, but using the large dry erase grid. Depending on the number of digits, the general rule of thumb or expectation that we have is that every number, every operation, every bracket, every symbol receives its own unique square in the grid. Now, obviously, that is not a hard and a fast rule, but it's a good place to start. Here's an example of a short equation to illustrate what I mean. You will see that even though the 4 and the x have been given their own separate squares, I have grouped them closer together for the ease of visual representation for the student. We also require our students to skip a line when showing their work. What is great about using the dry erase markers is that you also have the opportunity to incorporate additional colors to represent visual illustrations when moving numbers around, such as when we move the 8 from the left to the right of this particular equation. After we had worked through the equation together on the large board, my students then wrote the equations on grid paper that I had printed off for them, and this grid paper used larger squares than normal. This gave my students plenty of space to work, and each equation was inspected before we moved on. Take as many days as you need with this. Be patient with your students. Give them the opportunity to really get a handle not only on the new way of working, but on what your expectations are as well as their instructor. Be sure that you have your own unique expectations established in your own head before you begin, while still maintaining a degree of flexibility, as equations come in all shapes and sizes, same as our kids. Working together on the large grid board, these step-by-step equations quickly transitioned into the second stage of supporting our students. To do this, we provided each of them with a coil graph notebook. Quick hint, if you are looking for graph paper at your local stationery store or online, but are having problems finding some, try searching for the term quad paper, Q-U-A-D, quad paper. I learned this particular term a long time ago, and it certainly came in handy when searching for these notebooks. Searching for graph paper doesn't always yield the results you were hoping for. We began using the graphing books with existing equations, still not introducing any new concepts. Only focus was neatness and how to use the new format. For the first few equations, I did hover and I directly supervised the students as they worked, correcting formatting issues in real time as they progressed, reminding them about different procedures, expectations, giving tips, encouraging and praising the students as they went. I should also note that when using the graphing notebooks, we have the students only write their equations on the right-hand page, leaving the left-hand page blank for any equations they need to perform that are related to the questions on the right. We implemented this for two reasons. One is my students happen to be right-handed, and I wanted the coil of the notebook to be on the left of their work so as to not interfere with the hand movements and to defeat the neatness that we were trying so hard to instill. If your student is left-handed, however, you might want to consider reversing which side they work on. Secondly, we wanted to provide extra space where our students could perform additional mathematical functions needed to solve their equations. Yes, they could perform the extra equations on a reusable board or on a piece of scrap. However, that work that they do is then lost. And if the student is getting questions incorrect, or if they are just really struggling, I as their teacher am less equipped to help them if I cannot see their side work. That said, on the equation page itself, they are never permitted to just simply write out the final answer. They must always show their work on the right-hand equation page. The extra functions I'm referring to for the left-handed page are more the mathematical elements within the equation itself, such as what is 6 times 35 or 112 divided by 9. The neatness expectation of the left-hand page is certainly lower, but it's still there to ensure that they don't make mistakes. The students must group the extra equations on the left page under a question number so that we can cross-reference later should a need or problem or confusion arise. Once both myself and the students were comfortable using this new method, we then transitioned to independent work. Again, using existing concepts, but the students would hand in their work at the end of their assignment for marking. And now, finally, they were ready for new concepts. Keep in mind, each student is different. Take as long as you need to complete each of these steps for the greatest success for your student, and different students will work at different paces. What is the end result of all of this? Are we happy with how our students have progressed using this method? Was it worth it? Absolutely, hands down, emphatically, yes. Take a look at a before versus now sample of their work. Can you see the difference? I know I sure can. Now, do my students still need gentle reminders to keep their work neat? You bet. After all, they're kids. This is a process. It takes time. But the gains my students have made since implementing the new grids are leaps and bounds ahead of where we were. There is one change I might make yet, but I admit I am nervous about doing so. I am debating about applying a peel and stick white drawer liner to the back of this grid to not only preserve the grid itself, but to also allow me to place the grid in front of existing writing that might be present on the large whiteboard. Because the writing that's on the large whiteboard, I may not be able to erase right away when I need the board. But if I leave the writing on the whiteboard, it's going to interfere with the see-through acrylic of the large math grid in the front. But what is stopping me with going through with this idea of lining the back? Well, I know how hard it is to apply peel and stick liners or wallpapers evenly, level, and without bubbles. And I'm concerned that if I try to reposition the liner in the case of a mistake or misalignment, I'm going to end up actually removing or destroying the permanent marker of the grid. So for now, I am sticking with my grid as is. So be encouraged. By implementing a couple of very simple tools, you can help your student improve not only their neatness in math, but their skills and their accuracy as well. Thanks so much for watching. Don't forget to subscribe to the channel. Have a great day. We'll see you next time.